Welcome to the FLIR GX series tutorial that covers the basics of operating your thermal imager for gas detection. Before we start, it is important to remember that knowing how to use this camera is just the first step. To get the most out of optical gas imaging, thermal inspectors must also understand how to interpret what they are seeing. Conditions are not always optimal for optical gas imaging. In this example, similar background temperatures or wind can make inspections more difficult. That is why thermal inspectors need to understand these situations and know the right settings to use for the best results. And this happens with proper OGI certification courses from the Infrared Training Center. So if you're ready to get certified, watch until the end of this presentation for details on how to register for an upcoming optical gas imaging certification course. Throughout the year, the Infrared Training Center offers a number of these dates at convenient locations, including online courses too. Special offers may also be available. Head to infraredtraining.com to learn more. Next, let's discuss the basics of operating your FLIR GX series thermal imager. The FLIR G series line of optical gas imaging cameras are designed to detect a wide variety of gas emissions from multiple stages of the oil and gas industry and other industrial markets. All hydrocarbon, methane, and other volatile organic compound models are Quad OA, Quad OB, and Appendix K certified and provide the ability to quantify leaks. Additionally, the FLIR GX320 and GX620 are also ATEX compliant, making these camera models ideal for detecting gas emissions in refineries, petrochemical facilities, natural gas well pads, compression stations, and power generation plants without the need to pull a hot work permit. This tutorial will focus on the G series line of thermal imaging cameras, including the GX320 and 620, as well as the G343, 346, 304, and 306. The primary difference between these models is their ability to detect certain gases that are only visible at specific wavelengths in either mid or long wave infrared. The FLIR G series also works with FLIR Ignite, a cloud-based data management system that automatically syncs your saved data. This allows you to view and edit saved photos and videos, as well as generate inspection reports from any device using your Ignite account. We'll discuss FLIR Ignite a little bit later, but for now, let's move on to the basics of camera operation. To help demonstrate the camera's features and functionality, I have a FLIR coffee mug here, which we'll use as a target for these demonstrations. For those of you that want to follow along, feel free to pause the video, grab yourself a cup of coffee or a glass of warm water, and come right back. The FLIR G series comes with 2 batteries and a 2-bay charger compatible with all models. On all ATEX certified cameras, the battery compartment is accessed using the Torx tool provided with your thermal imager. Check the charge level by pressing the charge indicator located on the end of the battery before inserting it into the camera. To insert a fresh battery, slide it into the compartment with the contacts facing upwards. Remove the battery by simply pulling it out. The battery compartment also contains a USB port. This is used to connect the camera to a computer for data capture and analysis. An HDMI port is available to broadcast the camera display to a projector or video monitor. The memory card slot holds an SD card for data storage, and the 12-volt power connector is used to plug in your camera to either charge the battery or run the thermal imager over longer periods of time without interruption. Close the battery compartment and, if using an ATEX compliant thermal imager, tighten the screw to secure it into place. Press the power button to turn on the camera. The LED indicator light will turn green and a mechanical cooler will engage as the camera starts. Now, this sound is normal and essential to the functionality of the thermal imager. The startup process takes approximately 7 minutes, but can be longer when working in higher ambient temperatures. During this time, operators can still access the gallery and adjust the camera settings by selecting the run-in background on the display screen. When the camera is ready, the display will update and there will be a distinct change to the sound of the internal cooler. While we're waiting for the thermal imager to cool down, let's review the various control buttons and other elements found on the camera housing. On the front of the thermal imager is the infrared camera lens. Avoid touching the lens as it has a special coating that plays an important role in the camera's ability to see thermal radiation. If this coating gets damaged or worn off, it can affect image quality and temperature accuracy. Procedures on how to properly clean a lens can be found in your user manual. Operators should clean the lens as little as possible, so be sure to use your lens cover whenever you put the camera down. The digital camera captures visible light control photos and video when saving a thermal image. 2 LED lights found here help illuminate the scene and allow operators to capture better visible light photos and videos in low light conditions. Finally, a laser pointer is available to help guide the operator and indicate where the thermal imager is pointing. The right side of the camera features an articulating handle that rotates for better camera positioning. It also contains several important buttons and controls. The record button captures data using the selected recording mode. The first of 2 programmable buttons is located here. This button can be customized to run a function that is commonly used by operators. The slider offers different functionality depending on the camera model. For all non-ATEX certified cameras, pressing down on this slider activates the autofocus feature. Sliding it left and right also adjusts the focus of the camera using a built-in motorized focusing system. On ATEX certified models, these motorized focus capabilities have been removed to ensure compliance with this important safety standard. The slider on these models instead operates a digital zoom, allowing the operator to electronically magnify the displayed image. The joystick is used to access the menu system and navigate around the display. Pushing in on the joystick selects what is highlighted in the main menu and any submenus. The back button will back you out of the main menu or any submenu that you are viewing, eventually returning you to a live thermal image. On the back of the camera, besides the battery compartment, operators will see the viewfinder. This improves your ability to see your thermal data when working outside on bright days or in sunny conditions. Closing the display screen turns on the viewfinder. The diopter provides focus control for the viewfinder. Operators should adjust this to ensure the displayed image inside the viewfinder is always sharp and in focus. These are the neck strap attachment points. It is recommended that operators use the supplied neck strap when operating the thermal imager. The display screen located on the left side of the thermal imager closes into the camera housing when not in use. The mode wheel allows operators to switch the thermal imager between the various operational modes, as well as access the camera settings and review saved data. We'll discuss all of these mode options here in a moment. The laser button turns the laser pointer on and off. The second programmable button is available here and offers several additional options that we'll cover a bit later in this presentation. Finally, the temperature range button opens the range menu, where you can then use the joystick or the touch screen to move up or down, navigate through, and select from the available temperature ranges. Now that the camera is cooled down and ready to use, let's discuss the various control options and settings. The mode wheel switches the thermal imager between the various operational modes. Turning the wheel scrolls through these options. Camera mode is used to save thermal images. Video provides video recording capabilities. Time-lapse allows you to capture a sequence of infrared images over a defined period of time. Multi-rec allows you to save recordings of video sequences in different image modes. Quantification is used when measuring and quantifying gas leaks. Gallery is where you can view saved images and video. And Settings is where you can adjust a number of items, including the date and time, enable and configure Wi-Fi, adjust the display settings, and much more. For general inspection use and the purposes of this tutorial, let's set the imager to camera mode for now. The FLIR G-Series thermal imager is also touchscreen driven. Tapping the three dots at the bottom of the display opens the main menu. Pressing in on the joystick does the same thing and will be necessary if you are wearing gloves. In the main menu, pressing Mode Selection provides access to the same options seen using the mode wheel. There is also a hidden menu that you can access by swiping down from the top of the display. This provides the options to turn Bluetooth and Wi-Fi on or off, sign into your FLIR Ignite account to automatically upload saved images to the cloud, and activate the LED lamp to illuminate your target. The slider here on the right adjusts the brightness of your display. Swipe back up to return to a live image. Having the correct date and time entered into your camera is important for proper documentation and record keeping. These values are tied to each file when you save a thermal image or video and cannot be changed afterwards. To configure settings such as date and time, Wi-Fi, and more, navigate to the Settings menu using the mode wheel, the joystick, or the touchscreen. In the Settings menu, select the option for Device Settings. Next, select Language, Time, and Units. Under Date and Time, you should see options to set your time format, the date format, and the time zone. If you're connected to a Wi-Fi network, this should update automatically. If not, we'll show you how to connect to a network here in a moment. Use the fields to make adjustments to the date and time. Highlight the time field and press the screen or push in on the joystick to select. You can use your finger to scroll through and select the correct time, or use the joystick controls instead. Once the fields are set, press the back button to return to the date and time submenu. Repeat this process to set the correct date. When finished, press the back button to return to the Language, Time, and Units submenu. It's here that you can also change the units from Fahrenheit to Celsius, or the distance values from feet to meters. Many operators also prefer to have the time and GPS settings displayed on their saved images and video. All of these data points can be enabled in the Settings menu. Under Device Settings, navigate to Display Settings and select Image Overlay Information. This provides the ability to turn these data points on or off. Turning them on will display that information on your screen and in your saved data. Press the back button to return to the main Settings menu. You can also connect your thermal imager to a Wi-Fi network. This lets operators take advantage of FLIR Ignite. We'll discuss how to configure Ignite later in the presentation. To connect your thermal imager to Wi-Fi, navigate to Connections in the main Settings menu. Select Connect to Network and search for available networks. You will need your network key or password to access. Once connected, press the back button to navigate back to the main Settings menu. The range covers an interval of temperatures that the detector can accurately measure without going into saturation. You work within a range, and when saving images or video, all of the temperature data in that particular range is captured. This G-Series thermal imager offers 9 different temperature ranges, with the overall range capability covering -20 to 350 degrees Celsius. It may be possible to miss a gas leak if you are operating in the wrong range. Having these many ranges also improves the camera's ability to see small temperature differences, which can help with gas detection. To change the range, press the temperature range button located on the side of the camera. Then use the joystick to navigate up or down to select your desired range. Another option is to navigate to the settings menu using either the touchscreen or the mode wheel and select camera temperature range. Remember, range is not something you can change after saving thermal images or video, so be sure to have the correct range selected before capturing any data. The G-Series Thermal Imager offers two programmable buttons that are shortcuts to allow operators to access frequently used features. One of these buttons is located on the articulating handle next to the Save button, and the other can be found on the side of the camera in front of the display. Press and hold the P button for about 2 seconds to bring up a list of available functions. The Programmable button found on the articulating handle provides the following options: No action, which disables this button. Switch thermal and HSM. This will toggle the camera between regular and high sensitivity mode. We will discuss these differences a bit later in the presentation. Switch thermal and digital camera allows you to toggle your view between infrared and visible light imaging modes. And switch auto manual temperature scale toggles your settings between manual and automatic adjustment modes, which allows you to adjust the contrast and brightness of the thermal image. We'll discuss this further when we get to thermal tuning. The second programmable button, located on the side of the camera, provides additional functions, including the capability to hide the overlay graphics, auto-adjust the image, switch the delta T function on or off, or run a non-uniformity correction using Calibrate. We'll discuss how to run a non-uniformity correction a bit later in this presentation. Focus is a critical adjustment that is important for both leak detection and image quality. It is also something you cannot adjust after saving thermal data. ATEX compliant cameras offer a manual focus, while all other models provide both manual and automatic focusing capabilities. Rotate the lens housing to manually adjust focus. On non-ATEX compliant cameras, pressing down on the focus slider will automatically adjust the image. Moving the slider back and forth also operates a motorized focus adjustment. For autofocus to work properly, there must be sufficient thermal contrast between hot and cold materials. If your target is close to ambient temperature or has a very uniform thermal signature, autofocus may not work as well. Thermal tuning is the process of changing the temperature scale in the camera. This is called adjusting span and level. Modifying the scale changes the brightness and contrast of the thermal image, helping you better identify gas leaks. Whether you are in camera, video, or time-lapse mode, the option for temperature scale is available from the main menu. This is where you can switch between automatic or manual adjustment mode to thermally tune the image. The camera is typically set to automatic adjustment mode by default. This automatically changes the scale based on the hottest and coldest objects in the field of view. There may be times, however, when manual adjustment is required. An example is if you're trying to locate gas leaks against a more uniform background. Select Manual to make these adjustments. Pressing left or right on the joystick allows you to select one or both numbers. Once a number is highlighted, press up and down on the joystick to change its value. To demonstrate, I've highlighted the top number. Pressing down on the joystick lowers the value, narrowing the span. Notice how the contrast changes. We can do the same with the bottom number, again highlighting it by pressing left or right on the joystick. Once highlighted, pushing up or down changes the value. Highlighting both numbers together allows you to adjust level. This keeps the span fixed and instead changes the position of the scale within the range of the camera. In manual mode, you also have access to one-touch auto adjustment. Tap any area on the display to automatically readjust the scale based on where you have touched the screen. In this example, let's get rid of the saturation on the coffee mug. Pressing the screen once readjusts the scale. Finally, the virtual slider displayed on the image also provides touch control to adjust span and level. Simply tap which number you would like to adjust and then swipe up or down on the slider to either raise or lower that value. The FLIR G-Series comes with a number of different color palettes that allow you to add varying levels of contrast to the thermal image. Open the main menu and navigate to the color palette icon. Press the joystick to open the color palette submenu and use the joystick once again to select your desired color palette. These include Iron, Rainbow, Rainbow High Contrast, White Hot, Black Hot, Arctic, and Lava. Color palettes can always be changed after saving an image or video either on the camera or in your reporting software such as Thermal Studio or FLIR Ignite. Overcast skies or similar leak and background temperatures can make IR gas detection more difficult. High sensitivity mode is a feature exclusive to FLIR thermal imagers that makes it easier to detect leaks in these conditions. HSM uses real-time image subtraction to reveal subtle thermal changes between frames in your video feed and is an option available on either programmable button. Hold the button down for 1 to 2 seconds to open the options and select Switch Thermal HSM. Press the back button. Now, when you press the programmable button, the camera will switch from standard thermal mode to high sensitivity mode. When enabled, HSM makes it easier to detect these thermal anomalies. In this example, where it might be difficult to locate a gas leak using auto or manual mode, switching to HSM clearly shows the problem and its location. The FLIR G-Series thermal imager offers a number of measurement tools for operators. However, with gas detection, these measurements are not necessary or typically used during the inspection process. If a situation arises where you do need to measure temperature, these can be found in the main menu under the measurement icon. No Measurements turns off any selected tools and leaves the screen blank. The center spot provides a single point temperature measurement on the display. The hotspot turns on an area box and displays the maximum temperature from inside the defined shape. The cold spot does the same, but with a minimum temperature value. There are also 2 user preset options that operators can customize using these measurement tools. Now, while the G-Series offers a lot of functionality with measurement tools, remember that all of these can be accessed and modified in your reporting software. When using measurement tools, you also need to adjust the values for measurement parameters. These settings affect accuracy and must be set correctly when measuring temperatures. Navigate to the main menu and select Measurement Parameters. Here you can adjust the values for emissivity, reflected temperature, relative humidity, air temperature, and atmospheric distance. All 5 have an impact on temperature accuracy, with emissivity and reflected temperature being the most important. Use the joystick to highlight the desired parameter and press in on the joystick to adjust its value. Knowing the correct settings to use for measurement parameters requires a Level 1 IR certification training at a minimum. For now, please make sure you are familiar with how to change these in the camera and know that these can also be adjusted in your reporting software. FLIR G-Series cameras have a Delta T function that helps operators ensure they have a sufficient temperature difference between the ambient conditions or background and the temperature of the gas they are trying to detect. When this feature is enabled, the camera will highlight, using the color red, areas of the screen where there might not be enough of a temperature difference to see a gas leak. This feature helps operators know if they might need to consider a different viewing angle to change the background and help improve their ability to detect leaks. Open the main menu and navigate to the Delta T option to adjust these settings. The first column allows you to turn this feature on or off. The second allows you to set an ambient air temperature that is near the leak location. And the third option provides a temperature difference threshold that adjusts for the sensitivity of this setting. The non-uniformity correction is a function that resets the detector array and removes thermal artifacts displayed on the image. These anomalies are created when heat generated inside the camera or energy coming from the surrounding environment affects the stability of the detector array. These anomalies can appear to be warmer or cooler than the actual target and are most noticeable when you move the thermal imager around. The non-uniformity correction provides a cleaner image by resetting the detector and removing these artifacts. This function is available via the Programmable button located on the side of the camera. To enable this option, hold down the button until the functionality menu appears. Use the joystick or swipe along the touchscreen to navigate and select the option for Calibrate. Next, place the lens cover on the camera and initiate a non-uniformity correction by pressing the Programmable button. The word Calibrating should appear at the top of the display. Once complete, operators can now remove the lens cover and resume their inspection. Sometimes an operator might forget to place the lens cover on the camera before running the non-uniformity correction. When that happens, whatever the camera was looking at will be temporarily etched into the displayed image. This does not damage the camera or the detector. Simply run the non-uniformity correction again with the lens cover in place to fix the image. The FLIR G series saves both thermal images and video and provides additional options to capture time-lapse sequences or save images in multi-recording mode. These can be set from the main menu via mode selection or by using the mode wheel. Camera is for saving individual thermal images. Video captures a thermal video of a scene. Time-lapse saves a series of thermal images over a set period of time. And multi-recording allows the operator to set up a customized recording sequence. To save a thermal image, select Camera, point the camera at your target, ensure you have proper focus, and press the Save button to capture an image. Repeat this process to record a video using video mode. Switch to this mode and press the Save button once to start the recording and then once again to stop. The video file is then automatically saved. Time-lapse provides options to set the recording time interval and the total number of images that you want to capture. Select time-lapse mode and then navigate to the time-lapse option in the main menu. Here you can enter the time interval between each saved image and set the total number of images that you would like to capture. Multi-recording allows operators to configure a video recording sequence that utilizes 3 different formats while capturing data chronologically. This includes high sensitivity mode, thermal video, and digital camera. For each one, the operator can choose what type of data they would like to save, as well as set the desired recording length in seconds. Set the camera to multi-recording mode. If this is your first time using this feature, a prompt may appear asking you to set up and configure the sequence. Otherwise, from the main menu, go to Multi-Recording Settings. A total of 4 different sequences can be programmed. For each one, operators can set the desired format, which includes HSM, thermal video, or digital camera, as well as the time duration. Use the joystick to navigate to each one and configure the sequence. Pressing the back button returns you to the list where you can then configure the next one. Once these are set, press the back button to return to the main display. Pressing the Save button will now start a recording sequence, displaying the progress of each one at the bottom of your screen. Remember to stay fixed on the target until the entire sequence is complete. This feature ultimately makes it easier to standardize what type of video files are always captured, while also helping with regulatory compliance when specific data types are requested or perhaps desired. Navigate to the gallery where you can view all images and videos that have been saved. Use the joystick to select or tap on the folder to open. Video thumbnails are marked with the playback icon, while saved images display only a thumbnail picture. Use the joystick to navigate around the display or tap the thumbnail to open a file. With videos, you can press the playback button to review. Operators can then pause the video or exit playback by pressing the back arrow in the upper left corner of the display. Tapping anywhere else on the image opens a submenu in the upper right corner where you can delete the file. Saved images can then be reviewed using the same process. The menu option in the upper right corner opens a toolbar that provides access to additional features, including the ability to edit an image. Selecting this will open the image and show the main menu icon at the bottom of the display. Here you can adjust your measurement parameters, add measurement tools, change your color palette, adjust span and level, and more. Press the back button until you return to the main folder. The toolbar above also provides the option to sync your images with an Ignite account or add a new folder. FLIR G-Series cameras also provide the ability to remotely operate the thermal imager, stream its video feed, or upload saved images and video to any connected device using Wi-Fi and the FLIR Tools mobile app. First, download the FLIR Tools mobile app on your smartphone. Next, in the camera settings, navigate to Connections and select Share under Wi-Fi to connect the camera to your smartphone. Under Share Settings, you will find the network name and password for your G-Series thermal imager. Navigate to the Wi-Fi settings on your smartphone and look for the camera's network name and SSID. Select this and enter the password that's displayed on your thermal imager. Next, open the FLIR Tools app on your smartphone and toggle the switch in the upper right corner to start discovery and locate the camera on your local network. If prompted, allow the FLIR Tools app to find devices on this network, and the option to connect your camera should appear on your smartphone. Select Connect, and when prompted on the G-Series display, select Trust to complete the connection. The two devices should now be connected. 3 options should be displayed, including remote control, stream, and import. Remote control allows you to remotely operate your thermal imager using the interface provided on your FLIR Tools app. To demonstrate in this example, we are running the camera with our smartphone and changing the color palette from iron bow to rainbow. Stream works in the opposite manner, where the operations on your thermal imager are mirrored in the FLIR Tools app on your smartphone. Here, an observer can watch in real time as the camera operator changes the span and level of the displayed image. Finally, import allows you to offload files from the camera directly into the FLIR Tools mobile app, where you can review videos or edit thermal images from the device. FLIR Ignite is a cloud-based data management system that saves your images, keeps them organized, and provides the ability to generate reports. Users create an account and, when connected to Ignite via Wi-Fi on their thermal imager, any data they save is automatically synced with their account. To get started, let's first set up an Ignite account. Open a web browser and head to ignite.flir.com. Click Sign Up or Sign In to create an account. Enter your email address. This will be your username. Then select Continue, where you'll then be prompted to enter and create a password. After reviewing the terms and conditions and acknowledging that you've read them, follow the prompts that introduce you to Ignite and its many features. Now, Ignite offers a lot, so we'll be covering more of that in another tutorial. For now, just make sure to get your account established so that we can connect your camera. To connect your camera with FLIR Ignite, first check that it's connected to your local Wi-Fi network. Navigate to Settings, select Connections, and choose Connect to Network. Look for your local network and, if prompted, re-enter your password. Once connected, back out to the main settings menu. Tap the FLIR Ignite option at the top of the screen and select Sign In. Here you'll see two options for connecting a camera. A URL is available if you prefer to do this via a web browser, or you can use your smartphone camera to scan the QR code. Let's try that. Open the camera app on your smartphone and look at the QR code. A web link should appear. Click the link and you will be redirected to the FLIR Ignite website. Once the page comes up on your phone, sign in using the username and password that you just created for your new Ignite account. Once logged in, the 8-character pairing code displayed on your thermal imager should also automatically appear in your phone's web browser. Select Start Pairing and wait for a confirmation to appear that it has been successful. The camera display should change and your registered name will now show up. This confirms that you are now connected to your FLIR Ignite account. Press the back arrow in the upper left corner to back out. This should display your account information, including your email address, a status bar showing how much storage remains on your account, and an option to switch auto upload on or off. Let's leave it on for now to take full advantage of Ignite's ability to back up our thermal data. We hope you've enjoyed this overview of the FLIR G-Series Thermal Imager. If you have any questions or need additional help with the camera or software, the following pages are available for thermographers on the FLIR support website. Here you'll find a summary of key features, additional technical information, user guides, frequently asked questions, and much more. However, learning how to use the camera and the software is just your first step. It's only with certification training that you'll get the most out of your investment in this technology. And that's where the Infrared Training Center can help. Increase your credibility, enhance your career, and build your business. These are just some of what you'll accomplish with certification courses from the Infrared Training Center. Whether you're joining us in the classroom, on-site, or online, our course schedule is packed with upcoming training dates at a number of convenient locations worldwide. Learn from industry veterans and thermal imaging experts who will help guide you through interactive and practical educational experience with training that meets or exceeds industry standards.
I would 100% recommend this program to friends or colleagues. A little bit of knowledge with this technology can really go a long way and alleviate these problems that affect us all.
Don't wait. Join us for certification training with your G-Series Thermal Imager. To register, give us a call or go to infraredtraining.com to learn more and start your journey towards certification with the Infrared Training Center.